Hello, everyone, and thank you for joining us. My name is Leanna Russell, and I am the marketing coordinator here at Kramer. Today, I'd like to introduce you to Tom Copen. He is Kramer's Global Engineering Specialist, and he will be diving into the topic of 4K and explaining what Kramer has to offer. At any point in time during the webinar, if you have a question, please feel free to type it into the Q&A box. We will address as many questions as we can at the end. Also, I will be sending out a recorded copy of today's webinar, so if you have any additional questions, we can chat more at that time. Tommy, the stage is yours.
Okay, hi guys. So again, today we're going to be talking about 4K, HDMI 2.0, as well as HDCP 2.2. So getting into this here. So just to kind of set the stage, obviously 4K is mainstream media at this point. You know, if you walk into Best Buy, you'd be hard pressed, not to find a 4K TV. But just in general, with all these things, with new technology, it's like, do we really need it? So just the idea with as you have these different size screens when you have 4K, knowing that at certain distances when you're away from the screen, depending on the size of the screen, you're really not going to tell the difference between 4K compared to 1080p anyway. So again, obviously we live in reality, 4K is a thing, but just in general, with a 55-inch TV, in order to actually see, to be able to tell the difference between 4K and 1080p, you'd be sitting at 3 feet away from the screen. Again, that's with a 55-inch. So yeah, it'll get a little farther away for larger TVs, but I think you can see how normal people aren't sitting that close anyway. So at the end of the day, all this 4K stuff, while it's very nice, for most people, they're not going to be able to tell the difference. Something to look at here when you're talking about 4K, we're really talking about two different resolutions. One of them is your 4K cinema standard, kind of where you actually get the 4 from, but this standard is a viewable pixels of 4096 by 2160. Again, it's a 17 by 9 aspect ratio. Again, more for cinema and things like that. What we as Pro AV and consumers are probably going to see more and more often, especially when talking about 4K flat panels, is your normal UHD, Ultra HD format, which is 3840 by 2160. So that's the one on the right-hand side there. Your normal 16 by 9 aspect ratio, the size of your image is actually 4 times 1080p. So you can see your 1920 by 1080 square there down in the bottom left corner. Again, it kind of takes 4 of those, 4 1080p size screens or pixel count wise to be able to make your single 4K image. One thing to notice though, although these viewable resolutions are different, the total pixels that are actually comprise the signal as far as any kind of electronics are concerned is 4400 by 2250. So if you've ever heard from any of our other classes before talking about bandwidth, what you see is not the whole picture. There's always, blanking period and ancillary pixels that we might not see but are part of the signal. So again, here you can kind of see that both resolutions are identical. And if you go on our website and use our bandwidth calculator, you can kind of see that when you do calculate bandwidth, you are doing the calculation based off of total pixels, and not necessarily just what you see with your eyes. So when it comes to anything, as far as trying to figure out whether a resolution will work or not with a certain type of electronics that you have, the best thing that you can really do is calculate the bandwidth and just find out that, hey, you could have an oddball resolution, but as long as it's under whatever the max is that we support, that's what you'll end up going with. But again, on Kramer's website, just under support, we do have this bandwidth calculator. Allows you to select all types of common resolutions and color depths and other things, and we'll kind of fill it in for you, or you can type in your own. So moving on. So talking about 4K, you have to realize that there is really two different types of 4K. So on the left-hand side here, we have our full 4K image, which is the full 18 gigabits per second of bandwidth. So to have an 18 gig signal, you have to be using HDMI 2.0. You're going to have a maximum of 444 color sampling. So your 444 being the full, no subsampling at all, just full picture. You'll be able to do 60 hertz. You can have deep color. Of course, when you get into this larger bandwidth, shorter distances becomes a thing. So just be aware that as you get longer and longer or higher and higher bandwidth, our total distance that one could go on a cable is going to get shorter and shorter. Currently, with a full 18 gig 4K signal, we have no twisted pair transmission without any kind of compression. So if you do see anything on the market that does say that they can do 18 gig 4K 444 60 hertz, over a twisted pair cable, that's because they're doing some kind of compression on the transmitters and receivers. With fiber, yeah, we can do a full 18 gig data transfer. And also with this full 4K, you're going to end up getting into things with HDR. We'll talk about some more of these items as we go further in the presentation, but this is kind of just the overview. So the other side of things is, here is labeled as compromised 4K, where the bandwidth is really like 8.91 gigabits per second. So this kind of falls into, if you remember HDMI 1.4, the maximum bandwidth for HDMI 1.4 was 10.2 gigabits per second. So some of the 4K signals actually fall into what you can use in HDMI 1.4, and as well as some of those also go into HDMI 2.0. So we'll kind of get into both. If you're going to end up doing 4K at 60 hertz with this lower bandwidth signal, 8.91 gigabits per second, you're going to have to subsample your color to 420 subsampling. Again, we'll kind of get into this more later on, but if you want to do full 60 hertz, you need to sacrifice some color. Whereas if you want to do full color, you're going to have to sacrifice some refresh rate and go with 30 hertz. Again, depending on the resolution you got, deep color is going to be a question, just because again that adds so much more bandwidth. You can do longer cable runs, especially compared to your 18 gig signal, because again we're talking about less than half of your 18 gig signal. Obviously, this supports twisted pair with any normal HD-based transmitter receiver. And remember that with HD-based 2.2, although they're introducing fiber, it's still HD-based. So with the HD-based 2x2 or on fiber or anything, there is no bandwidth increases. You can just do longer distances over fiber. So in the previous column where we say fiber full 4K 18 gig, it doesn't mean that all fiber supports that 18 gig. So just be aware of what you're doing. Also with the 8.91 gigabit per second 4K, you're not going to be able to do anything with HDR. So we'll get into more of these things as well. This is kind of a great chart to have. This is kind of straight from the hdmi.org website, but it shows all of your resolutions and color sampling and color bit depths, which are all things that add up to bandwidth. You can see that at the top couple rows before that dotted line, this is what is covered with HDMI 1.4. So you have your 1080p's in all your different color depths. Obviously with 1080p, we never really thought about color sampling before, so it was really all, all 444 pretty much. Then when we get into 4K, your 2160p, again, we can do 30 hertz at a 422 with some 422 color sampling, but we have to, and there you can do some higher color depth. But probably the main one that you'll end up seeing is, your 2160p, so 4K, 444, but at 30 hertz. That's kind of where HDMI 1.4 really stops supporting those resolutions. And you'll notice what's interesting is that, even though the two resolutions straddling the line here between HDMI 1.4 and HDMI 2.0, we have both end up with the same bandwidth. So again, that 8.91 gigabits per second, whether we're talking about 4K 30, 444, or 4K 60, 420 color sampling, they both end up with the same bandwidth, but the 420 resolution falls under the supported capabilities of HDMI 2.0. So, and then obviously HDMI 2.0 goes all the way up to, your full 18 gig resolutions as well. But one thing just to be aware of, as with all HDMI versions, for a manufacturer like Kramer or like anyone else, to say that we support a version of HDMI, you really only have to support one of the features of HDMI 2.0, as long as you express in your documentation what feature you're talking about. So a product, any product, could say, hey, we're an HDMI 2.0 product. That does not mean that your product can do a full 18 gig 4K. They might support only 4K 60 420 at your 8.91 gigabits per second and call yourselves HDMI 2.0. So again, just know that you can't just look for HDMI 2.0 and know that it can do a certain amount of bandwidth or a certain amount of resolutions. You do have to look deeper. As far as how Kramer likes to differentiate its products, you'll see on our website or within our documentation that we sort of have three different ways, because there are three different ways of talking about 4K. So your top one here, our VP732 scaler, supports 4K 30 at 444. So that means that's an HDMI 1.4 product, and we have that little gray 4K logo next to it. So yes, we do support 4K, but it's maxed out at that HDMI 1.4 specification. The next line there is our DIP20. So this one supports 4K 60. This one supports HDMI 2.0, but the maximum resolution, you can see the maximum bandwidth that it supports is 10.2 gigabits per second. So therefore, we're able to, again, claim HDMI 2.0, but we're only supporting 4K 60 at a 420 color subsampling. Again, which puts us back down at that 8.91 gigabit per second total bandwidth, which is, again, lower than 10.2. So again, we have another icon for that. It's 4K 60 with the yellow ring. And then the last one, which is sort of the full-blown, max 4K, is a product like our VS211H2. So you'll see the symbol for that is 4K 60 444, which obviously is pretty blatant. It says we can support products that are 4K 60, refresh rate with a 444 color sampling, which again means no color sampling or subsampling. And we have a maximum supported bandwidth of 18 gigabits per second. So that product will be able to support any resolution. Again, you'll find on our website you can filter products based on this kinds of stuff. So on the left-hand side, you can see that you can filter between those three versions. In the descriptions, we talk about it as well. So, we want to be as transparent as possible, knowing that, sure, we play the HDMI 2.0 game and call ourselves that when we're, supporting 4K 60, because it is, that is part of HDMI 2.0. But we want to be as transparent as possible anywhere in our literature to show, hey, these are the versions that we support. But know that every manufacturer is going to be different here, and obviously everyone wants a marketing edge of some kind. So some people will do some things that aren't for the end user's best benefit. Okay, let's talk about some color subsampling things. So let's start with the human eye in general. So your human eye has two different receptors, rods and cones. The rods in your eye are used for grayscale and brightness, where your cones are strictly about color. Now, as far as compression is concerned, the good thing about the human eye and compression in general is that a lot of compression can be done just by removing colors and keeping the grayscale and brightness where it is. And again, that works out really well for the human eye because we have many, many, many more rods, which again are used for grayscale, than we do compared to our color reception. So just in general, a human is much more receptive and can notice grayscale changes a lot more than color changes. So you'll see here in this slide where it shows the differences between the things here. So at 444, again, there's no subsampling, so you get full colors, however, the full range of color. When you get into anything that's subsampled, so again, whether that's 422, 411, 420, what you're really doing is you're forcing pixels to share colors. So in the top diagram, you can see that there is a teal and a blue in the upper right-hand corner. You move that down to 422, and now we're just going to kind of merge those colors together and say, okay, now you have to be one color instead of being those two colors. And you go all the way down to 420, we've taken that entire block and just said, you know what, it's mostly blue, so we're just going to use blue. So that's sort of how subsampling works. One thing that's interesting, again, it seems like, oh my gosh, this is so terrible. Oh, and sorry, before I move on to that, you notice that the Y channel, remains the same no matter what. So again, that brightness and grayscale always stays the same, whether you're talking about any of these subsampling rates. Again, we're only compressing what is the easiest for the human eye to ignore, which is your colors. But again, it might seem terrible that we're doing all this, or not Kramer, but the industry. But just something to keep in the back of your mind, as far as 420 subsampling is concerned, anytime you've watched a Blu-ray movie, that's how they start. On that disc is not on a 444 signal. On that disc is a 420 signal. So sure, the Blu-ray player itself might scale up the color and do things like that, but obviously that's just recreating colors that originally were packed in 420. And I think Blu-ray movies look pretty good. Again, anytime you've looked at H.264, H.265 video, or even your Comcast or DirecTV or whatever cable service you might have at home, all that is done in 420 also. So you're probably more used to seeing 420 content than you are 444 content. But obviously, anytime you plug your computer into a display or something like that, computers are going to give out full 444 color. Again, this is sort of just a difference between the couple different ones here. I think that the goal of this slide is just to say, hey, there's really not that big of a difference. But you can see as you go down in the list of 420, again, certain pixels are just forced to share more colors. So you're going to lose some of that color clarity that you might see in 444. This is also a interesting test. This is a subsampling sort of test pattern where you might not be able to see it. I'm not sure actually how WebEx compresses things, so maybe you guys can see it and I can't. But the last two lines where you have the red background and the blue background with the red and blue lettering, if you pass this signal through a 420 subsample, you will not really be able to read those bottom two lines very well. Again, just the way that the colors get compressed here, a lot of the letters will look garbled, or you won't see certain parts of certain letters, where everything above those you'll be able to read just fine. So that's, again, kind of with any test pattern, it's a very exacting thing, but it's one way to test whether you're doing full bandwidth or subsampled, is to kind of run this test pattern through your system. So the one thing that to kind of take out of this, and we're talking about color subsampling, then we're going to talk about now with refresh rate. It's all about a game that you can play sort of if you need to stay at least below that. If you can't do full 18 gig, but you still want to have 4K, you kind of have to choose, well, where do I want to sacrifice? Do I want to sacrifice on a refresh rate where I know I can get, if you use a lower refresh rate, you can get full 444 color, or do you say, okay, I want a full refresh rate and I'm willing to sacrifice some color? Because at a 60 hertz, you're only going to be able to do 420. So that's sort of the game that we have to play unless you get a full 18 gig backbone for all of your devices. And again, there's good cases for both. But anyway, with refresh rate, it's all about what kind of content do you have. Obviously, if you have static content like a PowerPoint slide, it doesn't matter how many times my PowerPoint slide here is being refreshed because I'm not changing anything. So your static content, can have a very, very low refresh rate, and you'll never see the difference. Whereas if you're watching, sports, or if you're doing something else where there's a lot of movement in the image, then, your refresh rate does matter because you don't want to see a choppy image with a lot of motion and a low refresh rate. You want to try and bump up that refresh rate as much as possible so you don't see any motion blur and you get the crispest image with motion. So again, I think just to make a couple examples, if you're really into, let's say, like medical stuff where that color is very important, a little gray here, a little color there could be the difference between, whether a patient has a problem or doesn't have a problem. Where in that case, refresh rate might not be that important because they're looking at images. Then maybe, okay, I need to have 30 frames per second because I need that 444 color sampling. Where again, if it's something like a movie or TV, you can kind of sacrifice color, but you want that better motion. Another thing to be aware of, so this is a NEC 4K display that, is just part of our testing here in the office. And one thing to notice is, this is the same model display, just has a bunch of different connectors. If you look on the DVI port, you can see that the bottom line here, the native preferred timing, is 3840/2160 at 30 hertz. Where if you look at the HDMI or DVI port, you can see that the supported native resolution is 3840/2160 at 60 hertz. So there's a couple things to learn from this. One thing is that every connector on the TV might be different, might support different resolutions. Here, one being 30 hertz and one being 60. Also, it's just good to know that if you were running, let's say you have I already have my 1080p matrix switcher, so I'm going to keep using that, but I'm going to upgrade to some 4K displays. Again, it's not the least common thing in the world, but knowing that if you read EDID from the NEC's HDMI input onto a matrix switcher that only supports 10.2 gigabits per second, the EDID is going to be telling the source to output a 4K 60 444 signal in this case, which is not going to be supported by that matrix switcher. So again, it's all about EDID and knowing which EDID to put on your inputs for whether you have DAs or matrix switchers or whatever, whatever Pro AV product you might have. But know that whatever EDID that you store, make sure that your product down the line can support all those resolutions and bandwidth especially. So looking at the full specification of HDMI 2.0, again, we have a maximum bandwidth of 18 gigabits per second, which correlates to a 600 megahertz pixel clock. The resolution supported can be 4K, 50 or 60 hertz. Again, you can kind of say it's a full 444 for those resolutions. It does support the 420 color sampling, where again your HDMI 1.4 did not support 420 subsampling. You can do 32 audio channels. Audio sampling rate got higher. You can do some creative things with simultaneous delivery of multiple video streams. So again, you might not be able to do 4 or 2 4K 60 444 signals, but let's say 2 1080p signals are still less than, or even 4 1080p signals, is equal to the bandwidth of your 1 4K signal. So we have examples of this stuff later. So simultaneous delivery of multi-stream audio to different users. So if you have different languages, certain people could hear some languages, certain would hear another. support for some wide angle, theatrical aspect ratios, and obviously everything is going to be synchronized together. So that's sort of the full specification here. Also some CEC stuff. But for a lot of people, if you talk about 4K, they would tell you that 8-bit color just isn't enough for 4K. 8-bit color is really what we're used to using all the time with 1080p. Sure, there's Blu-ray players and things that'll upscale you to 10-bit color, but for the most part, what you see is 8-bit color all around. So, sort of, what's the point if we're, unless you can move up to your full 18 gig where you can get your 10-bit color, your 12-bit color, is 4K really worth it? Another thing that you get with HDMI 2.0 is support for HDR, which is high dynamic range. Basically, HDR on your left, the image does not contain HDR, and on the right it does. HDR gives you more brightness levels to work with, and it's really something that can be very useful when, just like this picture, there's some parts of the image that are very dark as well as some parts of the image that are very light. So this HDR kind of allows you to support both. HDR kind of comes in two flavors. HDR is kind of like audio in the sense that, you might support Dolby, Atmos, or you might support DTS, HDMA, things like that. So there are standards that are in place for HDR. Currently, there's sort of two of them. Again, one is by Dolby, it's called Dolby Vision, and the other is HDR10. So these are all things just like the audio formats, you have to make sure that every device in your chain is compatible with HDR to get the benefits of HDR. So one thing also to notice is that HDR is only available for 10-bit color depth signals and higher. So if you're just doing an 8-bit color, which is going to be anything in your 10.2 gigabit per second maximum with 4K, you're not going to be able to do HDR until you get bumped up into an 18 gig signal. Again, this was sort of an example that, who knows if this will ever happen and be useful, but, HDMI 2.0 can support, again, two different video channels being sent down the same cable at the same time, where, if you kind of thought about 3D, for example, you could put these glasses on and one person could be watching, one movie, and another person could be watching another movie on the same TV at the same time, and neither of them would know that the other person is watching their movie. Again, you would get one frame, they'd get another frame, you would get the next frame. So kind of working like 3D on left eye, right eye, except it's two different pictures completely. Another example, again, that dual screen that they're talking about, again, with certain displays, you might have it where the driver can see one thing on the screen based on their angle to the screen, and then the passenger might see something else completely that the driver is not supposed to see. So passenger watches a movie while the driver can pay attention to the road. One thing to know with HDMI 2.0 and cables, so technically, the HDMI standard has not changed for cables, even with the introduction of 4K. So currently, your normal high-speed cables, the Category 2, which were the same cables that were always recommended for 1080p, will work perfectly fine for 4K. The circuitry that allows all the 4K stuff to happen is in the product. It's not in the cables. The only concern now is with distance. So really the maximum distance for let's say an 18 gig 4K signal is about 15 feet. And again, we can't go over twisted pair with it, so that's really the difference here between cabling. So again, find any specific 2.0. If anyone is claiming that this is a specific HDMI 2.0 cable and they're trying to convince you that you need to upgrade your cables, that person, sure, they might be selling cables that will work for 4K, but they're trying to trick you into upgrading. So anyway, something that HDMI has done, HDMI.org has done, is they've created a new standard for HDMI premium cables. So again, this is just a certification for high-speed cables that they support all the newest technologies that HDMI is coming out with. I think, HDMI was kind of getting sick of people, claiming that their cables, sure, they're high speed, but they're not doing all these other things that HDMI is capable of. So again, they came out with a certification. Kramer is certified in these. I know we've already been getting a lot of requests from consultant bids and things like that, where the HDMI premium certificate is needed to be able to bid on these jobs. So again, Kramer has that certificate, and we'd be happy to give it out to anyone who needs it. This is just Kramer's, cable offering, and obviously we keep track of as much as possible, what cables support what resolutions. So all of our support 4K in one version or another. Again, what you just might find is that, again, the distances are determining whether you're going to get a full 18 gig or not. So for the most part, anything that's supported, 1080p, especially at a 12-bit color depth, is going to support any of the 8.91 gigabit per second 4K signals without a problem, sort of at any distance. It's really just your 4K 6444. Again, it's a huge jump up to 18 gigabits per second. So most cables over 15 feet are not going to work anymore. So just something to be aware of. Again, this will all be information you can find on our website for all our different types of cables when you're going to purchase. So what can we do to overcome distances? The first thing, Kramer has a new HDMI repeater out there. So it's a full 18 gig product. Again, we support HDCP 2.0. And what this basically allows you to do is double your distance. So like any of the repeaters we've had in before, if you have a cable that works, you can put this in the middle and do 2 of those cables. Obviously, if you find a cable that doesn't work, putting one of these on the end is not going to make it work. But here you could put, again, a 15 gig or a 15-foot cable to one of our repeaters and another 15 cable out, and have 30 feet as a maximum, again, at your 18 gig. Also, sort of the best way to sort of move these 18 gig signals around is really with fiber. So Kramer has a new line of fiber cables that are doing 4K 6444 up to 100 meters. We have plenum rated versions of them. They don't require any external power, and they are pull resistant to be able to be pulled through conduit and things like that. As you can see in the picture, it's a mini HDMI cable head, so it's a smaller head that actually has to get pulled through any kind of conduit or anything like that. And then once you've got it where you need it, you pop the full-size HDMI connector on, and you're good to go. Some things that we do have coming are these in DisplayPort as well as special jackets for rental and staging where the cables get beat up a little more than normal. So just with a thicker, heavier gauge jacketing around the fiber. But this is really the best way to get fiber longer distances and move it around. As you can see, we also have, because that head is detachable, we can have a DVI head that could be put on there as well. So depending on what kind of connector you had on your TV, we can make either of those happen. Again, as far as testing for 18 gig, as far as Kramer's concerned, we do use the newest quantum data testers in order to verify that our cables are, good enough at all different types of resolutions as well as bit depths. Again, this allows us to see especially what cables don't work. You'll get all kinds of errors and things like that. One thing that sort of also came around with HDMI 2.0, although not exclusively, is HDCP 2.2. So it's a new standard for encrypting 4K. I mean, it's just like HDCP before. The idea is to make sure that any high-value content is not copied or sent somewhere where it could be copied. So we should just know that HDCP 2.2, if the stream is labeled with a high content flag, which is basically going to be your real 4K Blu-ray players when they're playing, playing a 4K movie, they're going to have a little flag that says this is high value content and will only work with devices that are also HDCP 2.2 compatible. If the Blu-ray player finds that one of your devices downstream is not HDCP 2.2 compliant, it's going to downgrade its output to be 1080p. So that's just one thing to be to notice, that you won't be in a situation where you won't get a signal at all. But if you're really looking for that 4K, again, you bought your 4K Blu-ray player, you're hoping to get 4K out of it. You better make sure that all of your devices downstream are HDCP 2.2 compliant. So this was just something that 4K and HDMI 2.0 kind of moved faster than HDCP 2.2. So back when 4K first came out, you might have displays that were 4K capable, but they didn't support HDCP 2.2 yet. So now I think everything pretty much is if you're buying new, but always something to be aware of. HDCP 2.2 works like anything else. As far as HDCP is concerned, there's a maximum number of devices you can connect and all these other things. But the main thing, again, this quote kind of at the bottom here, you might have HDMI 2.0 sources without HDCP 2.2, but you'll never have HDCP 2.2 sources without HDMI 2.0. So again, kind of just keep that as a rule of thumb. Kramer has a new 4K 18 gig HDCP 2.2 tester that we're releasing. What's nice about this tester is that it has an HDMI input as well as an output. So you can do a couple things. First, you can use it as a generator. Again, you can generate resolutions all the way up to your full 4K 444 60 hertz 18 gig. So to test the display or to test the going through products. What you can also do with the HDMI input is analyze your signal coming in. So if you're curious on what your source is putting out or where something is in a video chain, plug it into the generator here, and that black area on the front is the screen, and it will tell you what your resolution is, what HDCP is supported, and all these different things, what the EDID that it's seeing is, and everything else about your signal. So it can really be a useful troubleshooting tool when you're trying to decipher between all this bandwidth and what signals are where and stuff like that. So that's the planned presentation for 4K, HDCP 2.2, HDMI 2.0. If anyone has any questions, hopefully you put them in the Q&A area of the webinar, and thank you very much.
Thanks, Tommy. I don't see any questions. So if anyone does have any questions, we can definitely chat about it over email when I do send you the copy of this presentation. But I just wanted to thank everyone for taking the time out of the day to join us, and I hope you enjoyed the webinar, and I hope you found it informative. If you would like to see anything else about Kramer and our lineup of 4K solutions, you can always visit us at kramerav.com. Again, I will be in contact with you with a copy of the presentation, and I hope to talk to you more at that time. But other than that, thanks again, folks, and enjoy the rest of your day.